Today, I will show you divisibility rules for numbers 2 to 12. I will group them into different groups. 2, 5, 10 together, 3 and 9, 4 and 8, 7, 11, and 6, 12 together. So why do you need divisibility rules? So they are very, very helpful to solve problems involving large numbers. So if you can freely use the divisibility rules, you are able to quickly find factors of a number. You can quickly simplify fractions and simplify algebraic expressions and equations. Let's get started. I want to use the 12 by 12 timetable to show the pattern and then the rules. So let's start with 2, 5, and 10. So this is the 12 by 12 timetable for 2, 5, and 10. So we notice that all of the multiples of 2 are even number, and the multiples of 5 ends with either 5 or 0, and the multiple of 10 ends with 0. So if we want to know if a number is divisible by 2, 5, or 10, we only need to look at the last digit or the ones digit. So the rules for 2 is if it's even number or if the last digit is even number, it's divisible by 2. And if the last digit is either 0 or 5, it's divisible by 5. If the last digit is 0, it's divisible by 0. For example, for 18, because 8 is even, so 18 is divisible by 2. For 25, because 25 ends with a 5, so 25 is divisible by 5. And 80 ends with a 0, so 80 is divisible by 10. Now let's look at some problems. Which of the numbers is divisible by 2? So we only need to look at the last digit or the ones digit. If it's even number, it's divisible by 2. So the correct answer is C, 2,968. Which of the number is divisible by 5? Again, we only need to look at the ones digit. So the correct answer is B. And which of the following numbers is divisible by 10? Again, we only look at the ones digit. So the correct answer is A. Next, we will start the divisibility rules for 3 and 9. I would say the divisibility rule for 3 is the most important one. So this is the timetable for 3 and 9. So the divisibility rules for 3 and 9 both involve the sum of the digits. So for 3, if the sum of digits of a number is divisible by 3, the number is divisible by 3. So for example, 27. 2 plus 7 is equal to 9. Because 9 is divisible by 3, so 27 is divisible by 3. And the divisibility for 9 is quite similar. So if the sum of the digits is divisible by 9, the number is divisible by 9. For example, 108. So the sum of the digits is equal to 1 plus 0 plus 8, which is 9. And because 9 is divisible by 9, 108 is divisible by 9. So now let's work on this problem. Which of the numbers is divisible by 3? So to use the rule, we need to get the sum of the digits. So the first one, so we get 2 plus 1 plus 4, that is 7. And we know 7 is not divisible by 3. So 214 is not divisible by 3. So B, 2 plus 1 plus 5, that is 8. Because 8 is not divisible by 3, 215 is not divisible by 3. For C, 2 plus 1 plus 6, that's 9. Because 9 is divisible by 3, so C is the correct answer. But we also check D, 2 plus 1 plus 7, that is 10. 10 is not divisible by 3, so we know the correct answer is C, 216. Next question, which of the numbers is divisible by 9? So again, we calculate the sum of the digits. If the sum is divisible by 9, the number is divisible by 9. So for A, that's 8 plus 2 plus 1 plus 5, which is 16. Because 16 is not divisible by 9, the number in A is not divisible by 9. For B, 8 plus 2 plus 1 plus 6, that is 17. Again, not divisible by 9. For C, 8 plus 2 plus 1 plus 7, that's 18. 18 is divisible by 9. So 8,217 is a number that is divisible by 9. Let's continue. D, 8 plus 2 plus 1 plus 8, that's 19, which is not divisible by 9. So the correct answer is C. Now let's work on 4 and 8. Let's look at the multiples of 4. 4 times 1 is 4, and times 2 is 8, and then 12, 16, 20, and then until I'm going to use an expanded timetable to look at the pattern. And then when 4 times 24, that is 96. And then 4 times 25, that's 100. So after that, 4 times 26 is 104. 4 times 27 is 108. So note that the last two digits are repeating. 4, 8, and 16, and next will be 120. So the divisibility rule for 4 is if the last two digits is divisible by 4, the number is divisible by 4. So for example, 116. We only look at the last two digits, 16. It's because 16 is divisible by 4, so 116 is divisible by 4. So now let's look at 8. The multiples of 8 are 8, 16, 24, 32, 40, and until 124 is 992, and 195 is 1,000. And after that, similar to multiples of 4, the last three digits start to repeat. So the divisibility rule for 8 is if the last three digits in a number is divisible by 8, the number is divisible by 8. So for example, 1,024. We only look at the last three digits, 0, 24, or just 24. It is divisible by 8. So 1,024 is divisible by 8. So now let's look at some problems. So which of the numbers is divisible by 4? So based on the rule, we only need to look at the last two digits. So let's ignore the leading digit. So 14, 15, 16, 17, we know that 16 is divisible by 4. So the correct answer is C. Next, which of the numbers is divisible by 8? Using the rule, we only need to look at the last three digits. So we ignore the leading digit. So we notice that for B, 215, that's an odd number. We know for a number to be divisible by 8, it has to be divisible by 4 and by 2. So B is out because it's not divisible by 2. Now look at A. For A, the last two digits is 10, is not divisible by 4. So it's also not divisible by 8. So for C and D, we just do the calculation. We found that C is the correct answer because 216 is divisible by 8 and 236 is not divisible by 8. Okay, next is the divisibility rule for 7. It's very tricky. So now, let me give you the multiples of 7. So it's 7, 14, 21, 28, 35, and then 168, 175. It's really hard to see any pattern. So let me give you the rule. So based on the rule, we first need to double the last digit and then subtract it from the rest of the number and check if the difference is divisible by 7 or not. Well, let me explain. So if we separate the last digit from the rest digit, so as shown in these 5 numbers, so the last digits are 8, 5, 2, 9, 3, and then the rest of the number is 16, 17, 18, 18, and 20. To use this rule, we do a calculation. If we use 168 as example, we do 16 minus 8 times 2. That's the same as we first doubled the last digit with 8. So 8 times 2, and then subtract it from the rest of the number, which is 16. So the difference is 0. 0 is divisible by 7, so 168 is divisible by 7. Let's continue working on the other 4 numbers. 175, we do 17 minus 5 times 2. That equals 7. 7 is divisible by 7. And next, 18 minus 4 is 14. Next, 18 minus 18, which is 0. Next, 20 minus 6, which is 14. So if we see a number, we just do this way. We can get the last digit, double it, and subtract it from the rest of the number. So let's work on this example. Which of the numbers is divisible by 7? So let's first separate the last digit from the rest of the number. And then we do the calculation. For the first one, 21 minus 4 times 2, 21 minus 8, that's 13. The second one, 21 minus 10, right? 10 is 5 times 2, that's 11. For the third one, 21 minus 12, right? And the last one, 21 minus 14. So we notice that the last number, 21 minus 14, which is 7, is divisible by 7. So the correct answer is D. Next is 11. For the multiples of 11, so you can see that for the 2-digit numbers, they're just the same digits, same number at both ones and tens. But for the 3-digit and the 4-digit number, it's hard to find the pattern, right? So for divisibility rule for 11, we separate the numbers at the odd places and the numbers at even places. And then we get the difference between the sum of the digits at odd places and even places. If the difference is divisible by 11, then that number is divisible by 11. It sounds complicated, right? But actually it's pretty easy to get. For example, 528. So first we separate the numbers or the digits at the odd place and the digits at the even place. And then, so they are 5, 8 at odd places and 2 at even place. So we get 5 plus 8, that's 13, minus 2, that's 11. So 11 is divisible by 11, right? So 528 is divisible by 11. So next number, 539. 5 plus 9 minus 3, that's 11. Next, 3 plus 7 minus 1 plus 9, that's 0. Next, 1 plus 8 minus 4 plus 0, that's 11. Now let's look at one example. Which of the numbers is divisible by 11? So we first separate the digits at odd place and the digits at even place. And then it's pretty clear, right? For A, the difference is just 9. For B, the difference is 5. For C, the difference is 3. And for D, the difference is 0. We know that 0 is divisible by 11. So D is the correct answer. Let's have another example. 210. We get 2 plus 0 minus 1, that's 1. 1 is not divisible by 11. For B, so the digits at the, well, we can start with the even number, even places first. That's 1 plus 5, that's 6. Minus 2 plus 1, that's 3. So the difference is 3. 3 is not divisible by 11. For C, again, we notice the digits at the odd places is bigger. So we use 5 plus 2 minus 1 plus 1. So the difference is 5. 5 is not divisible by 11. So D, we use the digits at the even places minus the digits at the odd places. So that's 5 plus 9 minus 2 plus 1. The difference is 11. So 11 is divisible by 11, so the correct answer is D. So next is 6 and 12. For a number to be divisible by 6, that number has to be divisible by 2 and 3. So the rule for 6 is pretty easy. If a number is divisible by 2 and 3, that number is divisible by 6. So for example, for 72, so to be able to divisible by 2, it has to be even number, right? 72 is an even number. And to be divisible by 3, the sum of the digits is divisible by 3. 7 plus 2 is 9. 9 is divisible by 3. So 72 is divisible by 3. So 12 is similar. For a number to be divisible by 12, it has to be divisible by 3 and 4. So the rule is if a number is divisible by 3 and 4, that number is divisible by 12. For example, 348. So to be divisible by 3, the sum of the digits, 3 plus 4 plus 8, that's 15. To be able to divisible by 4, the last 2 digits. So you can see here, I highlighted the last 2 digits as red color. 48. 48 divisible by 4. So 348 is divisible by 3 and divisible by 4. This number is divisible by 12. Let's look at an example for 6. So remember, if a number is divisible by 2 and 3, that number is divisible by 6. So notice that B and D, they are odd number. So they are not divisible by 2. And for A and C, we need to get the sum of the digits. For A, 2 plus 1 plus 4, that is 7. 7 is not divisible by 3. For C, 2 plus 1 plus 6 is 9. 9 is divisible by 3. So the correct answer is C, because this is divisible by 2 and also divisible by 3. This example is on 12. So remember, if a number is divisible by 3 and 4, that number is divisible by 12. So for 3, the sum of the digits needs to be divisible by 3. And for 4, we need to look at the last 2 digits. For these 4 numbers, I want to look at the last 2 digits because it's easy to tell that there's only one number, C. Its last 2 digits is 16, which is divisible by 4. So the correct answer is C. Now let's go over the divisibility rules for numbers from 2 to 12. So for a number to be divisible by 2, that number needs to be an even number. So we only need to look at the last or the ones digit. So for 3, the sum of the digits is divisible by 3. So we need to look at all of the digits and then sum them up. If the sum is divisible by 3, that number is divisible by 3. For 4, we only need to look at the last 2 digits. If that number is divisible by 4, the number is divisible by 4. For 5, we need to look at the last digit. If the last digit is either a 0 or 5, that number is divisible by 5. So if you pause for a second, so 2, 4, 5, we need to look at either the last digit or last 2 digits. But for 3, we need to use the information for all of the digits. Okay, let's continue. For 6, that number is divisible by 2 and 3. So the last digit is even number, and the sum of the digits is divisible by 3. For 7 is a little complex. So we need to separate the last digit from other digits. So for example, 413, we use 41 minus 3 times 2. That's 35. If the difference is divisible by 7, that number is divisible by 7. For 8, it is similar to 4. We look at the last 3 digits. If the last 3 digits is divisible by 8, that number is divisible by 8. The 9 is similar to 3. We need to look at the sum of all digits. If the sum is divisible by 9, the number is divisible by 9. 10 is pretty easy. If the last digit is 0, the number is divisible by 0. It's similar to 2 and 5, especially 5. For 11, we need to separate the digits at the odd places and the digits at the even places. So the rule is, if the difference between the sum of digits at odd places and even places is divisible by 11, the number is divisible by 11. And 12 is similar to 6. For a number to be divisible by 12, that number needs to be divisible by 3 and 4. To be able to divisible by 3, the sum of digits is divisible by 3. And we also need to check if the last 2 digits is divisible by 4. Knowing the divisibility rules are very, very useful. I suggest you to memorize them, and it'll be easy or easier if you group them based on their similarities. Okay, if you are interested in applying these rules on more problems, check out my other videos. Again, this is Professor Wang. Bye.